minutes to opening of the capture window.
Endeavour Houston, looks like we're getting a good acquire through the ground stations and Moscow, so expect it at window opening.
Copy, Houston, and thanks for those words.
This television is from Zarya. This view looking down at Endeavour's payload bay. The two spacecraft currently passing above Russian ground sites. In view here, the capture fixture on Zarya on the left-hand side of the screen and the end of Endeavour's mechanical arm on the right-hand side. Less than 2 minutes from the opening of the capture window. Again, prior to the capture by Currie, Russian flight controllers will send commands to essentially turn off the motion control system on Zarya, avoiding any jet firings that could occur to perturb the capture while Currie moves in the arm to lock onto the fixture. Again, in this view, the capture fixture on the Zarya on the left-hand side of the screen, and on the right-hand side, the end of Endeavour's mechanical arm. About 40 seconds to the start of the capture window. About a 10.5 minute long window while Endeavour and Zarya pass above Russian ground sites for communications. Endeavour and Zarya currently 245 miles above Kazakhstan.
Endeavour Houston, we are pleased to confirm that Zarya's motion control system is off. You have a go for grapple.
Roger, go for grapple.
That call confirming that Russian flight controllers have turned off Zarya's steering jets. Endeavour is also in free drift now. Its reaction control system steering jets turned off as well.
Houston Endeavour. We have Zarya firmly attached to the orbiter. We're halfway home for the day.
A lot of people exhaling down here. That's great, and we had a terrific view from Zarya watching Nancy's great work.
That call with the arm firmly attached, latched on to Zarya now, as Endeavour and Zarya passed 242 miles above the border of Kazakhstan and Russia. Capture coming at 5:47 p.m. Central Time. This television through cameras on the Zarya.
Houston, Block 25 Alpha's in work.
Copy, thank you. Endeavour Houston, see you on Spec 20. Attitude maintenance is not required.
Roger that, Houston. Thank you.
Endeavour now moving into sunrise. As we continue to receive television from Zarya. We don't expect the opportunity for television from Endeavour for another 26 minutes or so.
Houston Endeavour for Block 25 Alpha.
Go ahead.
Chris, I know we're going to stay in free drift for a while, but we just wanted to put the next attitude in. Will that be the STS lighting on flight plan 3-34?
Endeavour Houston, we were just discussing it. Affirmative, that is a good attitude.
Copy that. We'll load that up and stay in free drift.
Again, we're continuing to receive live television, this from cameras on Zarya, looking down at Endeavour, and the mechanical arm of Endeavour as it's locked on to Zarya's capture fixture. We do anticipate the capability to receive this television for a couple more minutes before we lose communications through Russian ground sites. Endeavour and Zarya now moving above China. With the arm firmly latched on to Zarya, Currie's next operation will be to maneuver Zarya to the installation position, as it's called, a position which will place the docking mechanism on Zarya directly above the docking mechanism on Unity's upper mating adapter, with Currie aligning those precisely with one another, using space vision system markings to assist her in that procedure, and placing them within inches of one another. At that point, she'll put the arm in a limp mode, similar to the operations done yesterday for the docking of Unity to Endeavour's docking mechanism, and Commander Bob Cabana will fire Endeavour's thrusters to force the two mechanisms together. That procedure will take place also over Russian ground stations during the time to allow Russian flight controllers to have commanding ability and insight into the systems and communications with Zarya.
Houston, Endeavour for rendezvous.
Go ahead.
We show ourselves out of the rendezvous timeline and we're returning to the flight plan.
Concur. Endeavour Houston for cabin temperature.
Go ahead, Houston.
Roger, our remote thermometer here shows things getting a little warm. We had a suggestion, and that's to tap into the nice pocket of cool air that's on the other side of the middeck hatch. If you have time, we suggest the ODS volume prep for ingress, steps 6 through 15.
Okay, 6 through 15, we'll do it now. And Houston Endeavour, we got the cabin temp controller set at 12 o'clock. We can crank that colder also.
Bob, we copy, but looking at the mechanism downstream of that, it's doing its absolute best already.
Copy.
As we continue to receive live television from cameras aboard Zarya, looking at Endeavour and the mechanical arm latched on to Zarya. The crew's next procedure will be to maneuver Zarya into a position to be attached to Unity, to position Zarya's docking mechanism above the docking mechanism for Unity. For that procedure, Mission Specialist Nancy Currie will rely on the Space Vision System markings and...
Here's a question for you, Chris.
Go ahead, Jerry.
Are we going to have to go back through this procedure and close that hatch for the mating?
Jerry, that's the plan.
Okay, well, it takes a lot of moving of stuff around. Chris, the middeck is very comfortable. The flight deck is warm because of the attitude.
Jerry, we copy that. Our concern is, of course, the hot air blowing into the critical avionics. We were asking for a fluke meter temperature pickup, but if you say the middeck temperatures are comfortable, then, I mean, we're fine. We're just trying to help out.
If you're really concerned about the IMUs, we'll do it. I just want to let you know it's quite a bit of overhead. That's We'll give you a temperature reading on the middeck if you like that.
That would be great. Thank you.
To that call about temperatures on board, the temperature on the flight deck, the upper deck of Endeavour is 84 degrees. On the middeck, where there are not as many windows, it's normally much cooler than on the flight deck. Since sun coming through the window is normally a primary culprit for warming of the flight deck. So the crew was asked to take a temperature reading on the middeck to judge what the temperature is there. The concern being that the cabin temperature should be kept cool and on the middeck below 80 degrees for the cooling of electronics, which are located in bays underneath the middeck floor. Again, cooling in the cabin is also affected by the amount of electronic equipment up and running, as is the case, a lot of equipment up and running for the rendezvous activities today, and also by the fact that the air pressure on board Endeavour is lower than sea level. It's at 10.2 pounds per square inch, an equivalent air pressure to about 10,000 feet altitude here on Earth. That's done as part of the protocols in preparation for the upcoming spacewalks on the flight to reduce the amount of time that crew members would have to pre-breathe pure oxygen to purge nitrogen from their bloodstreams prior to going to the lower pressure still of spacesuits. So again, it's not anticipated that there's a problem, but the crew has to check with a remote thermometer the temperatures on the lower deck of Endeavour, anticipated, as is normally the case, to be much cooler than registering on sensors that provide telemetry here to mission control from the flight deck of Endeavour, which is registering about 84 degrees up on the flight deck. And again, that's due to the fact that there are few windows, only one window on the middeck of the hatch window versus all of the windows on the flight deck through which the sun comes and causes a fair amount of warming in the cabin. The mission specialist Nancy Currie aboard Endeavour is beginning to maneuver Zarya towards the pre-install position, to position Zarya's docking mechanism directly above the docking mechanism on Unity. The docking mechanism on Unity has the docking ring already extended and prepared for engaging the two mechanisms, as illustrated in this graphic from Mission Control. She'll position the two mechanisms directly above one another, precisely align them only inches apart, and then the final step in the procedure will be to put the arm in essentially a limp mode, at which time Commander Bob Cabana will fire Endeavour's thrusters to force the two mechanisms together and dock the Unity to Zarya. Zarya is the most massive object ever moved with the shuttle's mechanical arm at more than 21 tons. It's more than 3.5 tons more massive than any previous object maneuvered with the arm. The previous most massive object was the Compton Gamma Ray Observatory, which was released using the mechanical arm on shuttle mission STS-87.
Houston, Endeavour for Ecom.
Go ahead.
We took some temperature measurements. It's about 76 degrees on the middeck. It's 84 up by the instruments, and we concur with your recommendation. If you'd like, we're still going to do steps 6 through 15 on volume prep for ingress.
Endeavour Houston, that puts us underneath any limit concern. You do not need to do those steps unless you feel it's necessary for your own comfort. We're happy with the middeck temperatures.
Okay, Chris, thanks for that. We'll hold off, and we sure do appreciate it.
Thank you. Endeavour Houston, handing over Tidris West.
Roger. Endeavour Houston for total antennas. Slide out the other way. Houston Endeavour.
Go ahead.
Yeah, we got a good view of both antennas, and it looks like neither one of them deployed at all. They're not even partially deployed.
That's interesting. Copy.
Do you have downlink?
Unfortunately not with the free drift we've pitched out of the line of sight.
Okay, when we get back into attitude maintenance, you'll see it on the RMS survey.
This is Mission Control Houston. That call from Commander Bob Cabana about the Toru antennas on the Zarya module. Those had an indication that they had not deployed 2 flight controllers on the ground at Mission Control Moscow early on. They're part of the manually operated backup rendezvous system for Zarya. Not a system that would have an impact on future station operations. Through the arrival of the service module's docking is planned to be done with the Currie system, the automated docking system. That's a standard mode of operations for docking between large Russian modules. However, Cabana confirming suspicions that the Toru antennas had not deployed there with visual inspection of Zarya.
Endeavour, we want to know if attitude maintenance is required. And Houston, Endeavour, let me rephrase that. Do you have the OSDS attitude for us to maneuver to?
Endeavour Houston, we show it loaded. I think CJ got to it earlier, so you should just be able to do the item 19 with the auto to get there.
Okay, I guess I was a little focused on something else when he did that.
Yeah, there's 50 of us down here to watch it.
And confirm we got to go to maneuver.
Affirmative, you have a go.
This graphic from Mission Control illustrating the current position of Zarya. As a mission specialist, Nancy Currie aboard Endeavour continues maneuvering it into position, nearing a position called the pre-install position now, just above Unity's docking mechanism. From this, she'll lower the docking mechanisms, align them precisely to be within inches of one another, and then put the arm in a limp mode, essentially, while Commander Bob Cabana then fires thrusters on Endeavour to force the mechanisms together and dock Unity to Zarya.
Endeavour.
Go ahead, Jerry.
Okay, Chris, we're getting ready to do step 2 on FS4-6, docking mechanism prep. And Jim is getting started on step 3, OSVS setup on the next page.
Thank you.
Houston, down for PDRS.
Go ahead, Nancy.
Obviously, Chris, we're brakes on at the pre-install position. Looks visually like we might have a little bit of a wire, but we're going to wait here as we maneuver back to attitude and give it to Jim for SDS.
Copy. Thanks for the update. With the drift at attitude, we haven't had a chance to see any camera views at all. Appreciate it.
This is Mission Control, Houston. This television live now from Endeavour. Endeavour currently passing above the Southern Pacific. This view showing the docking mechanism on Zarya and the docking.
We're getting a quick peek. Looks like we're looking through camera Charlie.
Affirmative, I have set up the focal length to 15.1 and the focus to 20.0. So let me know if those guys can track these dots there, and I'll try to match what they do.
In this view showing the two docking mechanisms. For Unity and Zarya, as Mission Specialist Jim Newman also sets up cameras for the Space Vision System, an aid for alignment that Mission Specialist Nancy Currie is using to precisely align those docking mechanisms. The Space Vision System uses the dots and the markings on Zarya and on Unity to provide a digital display that is displayed on a laptop computer in the shuttle's cockpit to aid Currie as she operates the mechanical arm. Zarya and Unity here poised to make contact. The anticipated time of the docking about 7:36 p.m. Central Time. Two modules making contact for the first time.
Houston, Endeavour for SBS. I'm getting stuck on window 1 bad overlap status. Do you guys have that one going yet?
Jim, it looks like the lighting's improving as we're approaching the design attitude. We're unable to track to this point, same as you.
Okay, and just a few minutes to sunset. We'll try with the Bravo illuminator, which is on at this time. And now I'm going to try Charlie at night here with the Bravo illuminator, and I hope you guys concur with that.
We concur.
Thanks.
Endeavour's crew now extending the docking ring on Unity's docking mechanism. That ring that was extended and retracted yesterday following the installation of Unity on Endeavour's docking mechanism to check its function. Now driving it out to a full extension in preparation for the docking of Zarya. This live television, the ring can be seen at the top of Unity's mating adapter as it extends up.
No dots are running, working on the FGB for Houston and SBS.
Thank you.
FGB dots are running. Well, we've got everybody tracking. I presume you guys are too, and you probably already got a solution.
Roger, we're tracking here too, Jim.
Mechanical systems officer here in Mission Control confirms that the ring is fully extended now and the position ready for docking.
Endeavour Houston, we're 2 minutes to handing over to Tidris East. We will no longer have the downlink on the east. Jim, we've been getting various solutions going through the maneuver, of course, probably same as you. Could go to manual iris, might help through some of these changing conditions. Your call.
Yeah, I was debating that and looking at how long it was until dark and decided to wait for sunset. I'll go manual iris until sunset if you'd like.
No need. We're going to lose our signal in a minute. It was just a thought. We concur. Just wait for sunset.
Okay, and what did they get for an SCT vector?
Mission specialist.
Changing maneuver there. We never got a steady enough solution to get a worthwhile number.
Oh, pretty much in the same boat, but it didn't look too bad.
Mission specialist Jim Newman on board Endeavour, working with the space vision system, the orbiter space vision system, the alignment aid for the mechanic arm for Nancy Currie to use as she precisely positions the two docking mechanisms, Zarya's and Unity's. That system uses the markings on Zarya and Unity and the orbiter's closed circuit television system, cameras on the orbiter, to provide a precise alignment aid for the operator of the mechanical arm for Currie in this operation to align the two docking mechanisms. Once that setup of the space vision system is completed, Currie will begin aligning the docking mechanisms and maneuvering Zarya down to the installation position. The two mechanisms then only inches apart, ready for the docking of Unity to Zarya, done by firing Endeavour's thrusters to force the mechanisms together.
Houston Endeavour for STS.
Go ahead.
Okay, see camera in the dark here with Bravo Luminaires, SCT vector, as good as I can get it, it's a little noisy. 567.0 on average. Y negative 13.35. Z 97.06. And so I'm going to go do the CAS-CAL if you guys concur.
Jim, just stand by 1 sec, if you would, please.
Okay, I'll hold off on the CAS-CAL.
Endeavour Houston, Jim, if you could let us know the camera's pitch tilt angle, then we concur with your plan for the CAS-CAL.
Okay, say again what it is you're looking for?
Camera, pan, and tilt. We'd like to know the tilt angle.
I'm using the database values of, what's that, -9 and 37.
Okay, thank you. We're go with your plan for a CAS-CAL.
Okay, thanks. We'll go do CAS-CAL. And interesting enough, with the pitch of 37, we still got a vertical ST for the about 416, so I think we're good.
Roger.
Okay, the first CAS-CAL got me pitch negative .005, yaw .009, roll negative .543, and a little focal length .012. I'm going to leave the focal length alone and accept everything else.
Concur.
This is Mission Control aboard Endeavour. Astronaut Jim Newman continuing to work with the Space Vision System, ensuring that the alignment is precise. When Nancy Currie begins to move the Zarya Module to the installation position, a position that will have the Zarya docking mechanism precisely aligned above Unity's docking mechanism, setting those two mechanisms only inches apart. Then for the docking, Currie will put the arm in a limp mode, and Commander Bob Cabana will fire Endeavour's thrusters to force the two mechanisms together.
Houston Endeavour, STS.
Go ahead.
Camera aim vector is reference vector pitch 37.006, yaw negative 9.115, roll negative .650. And I'll get the SCTs and STT next.
Roger.
The PSEC is on average about .001.
Roger.
This is a graphic from Mission Control illustrating the current position.
The SCT vector is 566.9 on average. Negative 13.32. Of course, it hasn't changed from before, really. 96.9, 97.0. Pitch of negative .6-ish. Yaw of .1. Roll of .65. I'll get the STP. Houston, Endeavour for SDS.
Go ahead.
Okay, the SDP vector, if you're ready to copy, is X. Kind of noisy, but it's always less than 0.7, averaging about 0.4. I just had a short spike up to 1. Y is pretty constant, about negative .2. Z is averaging about 0. But it's plus or minus .3. Pitch is negative .05, pretty constant. Yaw is 0 plus or minus 0.05. Roll is very constant, negative .05. So that sounds pretty good. I'll go on and get the SGP.
We concur with the lighting you're seeing. That's promising.
Houston Endeavour for STS.
Go ahead.
When are you guys going to get downlink?
A little over 18 minutes.
Okay, if you'd like to use the time, is Steve available? We could probably use the time valuably. It's time to, we're going after Windows 1 and 2 on the FGB and having trouble tracking them. It's time to start deciding how we want to do that. Since you don't have data in the back room, is Steve available in the front?
Yep, he's on his way. We have a TDRS handover to Z here in 2 minutes, and he'll be talking to you shortly.
Thanks, appreciate it. And just having trouble, low contrast in the area problems on 1 and 2.
Roger. Endeavour Houston, we're with you through TDRS Z, and Jim, Steve, and I are standing by.
Great, okay, I've got binary video up, Steve, for our discussions, and I'm trying to assess the lighting on those FGB targets 1 and 2. It's pretty grainy, but 3 and 4 and 5 are holding. Should we try window sizing or contrast first?
Yeah, we tried it in the back room, and we turned auto size off on the large windows, and we put the large window sizes to 18, and we had Joy on the tracking for Windows 1 and 2.
Okay, that was in the line.
You dropped out, Jim?
Okay, so I'm going to Windows, and I'm going to make the large windows 18s.
Concur.
And then we'll take the wind dot root area coefficient. What do you want to leave that at?
At this time, let's not modify that coefficient.
Okay, so then we've got the 18s in large, so I'm going to select large windows, and then we'll turn auto sizing off.
That's correct.
And go preset and go manually acquire.
I concur.
This is Mission Control Houston now.
Is blue, auto sizing is now off. Preset, manual.
Now working with Mission Specialist Jim Newman aboard Endeavour is astronaut Steve McLean here in Mission Control. McLean, one of the developers of the Space Vision system, a payload specialist on shuttle mission STS-88. In the crew on board, still on schedule, continuing through alignment of the...
One still walks away, 2 holds. I'll go put graceful drag on.
I concur.
Working through alignment of the 2 modules using the Space Vision system. Checking camera views. The Space Vision system uses the markings dots on the Zarya and on the Unity module, and the orbiters, the shuttle's closed-circuit television camera system, to create a digital display that aids the operator of the mechanical arm to precisely align objects that are being maneuvered. Again, for these activities, it assists with the precise alignment of the docking mechanism on Zarya and on Unity.
No joy, Steve, with that.
Jim, there are 2 choices. We can take the threshold down to 0.3. And the second choice is to wait for the sunrise, and we'll probably go back to small windows and auto size at that point.
Okay, I want to keep fighting it here in the dark and do the best we can, and then when sunrise comes, we'll go to the other stuff.
I concur.
So contrast next. See, I'm tempted to tilt the Bravo camera up a little more, maybe get a little more light on, but I might lose the node ones. I'll go ahead and try Bravo camera up a little to get some more illuminator on there.
We copy.
This is Mission Control Houston again on board Endeavour. Mission Specialist Jim Newman continuing to work with the Space Vision system, checking that system in preparation for the alignment of Zarya and Unity's docking mechanisms. Endeavour will be coming back into sunrise on the daytime side of Earth in just about 5.5 minutes. At that time, the lighting conditions for the space vision system will allow it to begin further alignment of the two modules. The planned time for the crew to work with berthing or docking the Zarya 2 Unity rather entails about the next 50 minutes. There's no set time for when the docking will take place, and there is actually no requirement that that docking take place over Russian ground stations or over Russian communication sites. So the crew's on schedule. They have about 50 minutes left in the current plan to finish the docking mechanisms and attach Zarya to Unity. All of that proceeding as expected at this point.
The RAL solution right now, and it's X of 2.9, Y of minus 2.1, averaging about minus, now it's moving around a lot, minus 1.3. Z of minus 36.5, so that agrees very well with SCS, up with RMS. All the angles for are half a degree or less. They're all negative, negative .4, negative .3, negative .2. So once again, I'm showing right now X varying from 2.7 down to in the mid ones occasionally. So about 2 plus or minus a half is what I'd call it. Y of negative 1.5 and Z of negative 36 on average plus or minus dot a half.
Endeavour Houston, for OSVS, could you give us the PSEC as well?
This is Mission Control Houston. This television now is from camera on the Zarya, as Zarya has entered into communications range of the Russian ground tracking sites. Again, Endeavour and Zarya currently on the nighttime side of Earth, about 3 minutes from moving into sunrise.
002 plus or minus .0005. Not bad for nighttime with this Charlie camera.
Endeavour Houston, by our tally, the sun is rising for you. We are going to have video available when we come Tidris West in about 4.5 minutes. Plan is to get the camera Charlie solution as soon as you have what you need with the solution in daylight. Then we'd like you to pick up in step 4 of the FGB install with maneuvering to the install position and subsequent.
Okay, we copy all that, and give us a call when you guys have their solution. I know they'll get it pretty quickly.
Will do.
And if Steve is still out there, my plan is not to move a thing. As soon as we get in full daylight, I will, as you recommended, go back to small windows auto sizer.
Jim, I concur with that, with a reminder to turn graceful degradation off once we get into sunlight.
Yeah, I already turned it off, so it's not on now. Thanks.
Endeavour Houston for OSVS. We would like you to restore the threshold to the original value as well.
I didn't move the thresholds either.
We copy.
This is Mission Control Houston. We're continuing to watch television from cameras mounted on the Zarya Module via the Zarya communication system and Russian ground tracking stations as Endeavour and Zarya and Unity move into sunrise, currently passing above Russia.
Endeavour Houston, we're a minute away from handing over to Tidris West, and we're having a nice look through Zarya's camera straight down at the payload bay.
Roger. Houston, Endeavour.
Go ahead.
As soon as you guys get KU band, please let me know if you have any suggestions. I think we need to wait for full daylight on the Earth to light up these the nodes.
Jim, we have it now, and it looks like all the lights coming over the horizon, none of it's bouncing off the Earth yet.
This television live from Endeavour, and that call, the crew, Jim Newman recommending that flight controllers and the crew wait till lighting conditions improve on the space vision system markings from this camera view until the sun rises higher to provide better lighting, to check the alignment of the docking mechanisms that checked using the space vision system. That system uses markings on Unity and Zarya to provide a readout of precise alignment for the two modules. Endeavour and
Houston, Endeavour for STS lighting.
Go ahead.
Yeah, I'm trying to understand what we're going to get. Are we going to end up having the Earth lighting up the back of the payload bay here, or this is going to be like what it's like? And how long will it take before they think STS lighting with the predict is good?
We'll check.
Endeavour currently at 240 miles above central Russia. Course that will take it southeast across South Asia. This view from a camera located in the aft right-hand corner of Endeavour's cargo bay.
Houston, Endeavour for STS.
Jim?
Yeah, I think we're in an inertial latitude, and correct me if that's wrong, and it'll be quite a while before the Earth gets behind us enough to light up the node. Do we want to just go ahead and press on while you guys think about what the lighting be? I don't want to lose the SPS opportunities later on waiting for one now.
Jim, we would like you to take advantage of this opportunity using iris and such on the camera to get the contrast that you need for the targets.
Okay, we're at it.
It's a live television view from Endeavour. The camera on Zarya, which has been providing television views through the afternoon, can be seen on the left-hand side of the screen, on the left-hand side of, or rather on the left side of Zarya in this view, just above where Endeavour's mechanical arm is attached. And the view from Zarya, from that camera, in the right-hand box, also double view. Again, the camera positioned just above where Endeavour's mechanical arm is attached to Zarya. Mission Specialist Jim Newman aboard Endeavour has opened up the iris on the camera in the aft right-hand corner.
Suggestion, Houston, we've got answers, and I presume you do too. We've got X is about 1 plus or minus, X is about 0.9 plus or minus 0.1. Y is negative decimal 7, negative decimal 6 plus or minus about 0.2. Z is negative 36.6. Y is negative .4. Pitch is negative .2. O is negative .1. P set is less than .001 most times, so 009 plus or minus 2 or 3. We'll store the data and press on if you'd like. Good suggestion on forcing the iris.
Jim, that's very similar to what we're seeing here. You have a go to continue.
Got it. Cameras are going over to Nancy and Bob.
Again, Mission Specialist Jim Newman opening up the iris on the camera located in the aft right-hand corner of Endeavour's cargo bay to get a better view of the space vision system markings on Unity and Zarya. Following that, that provided a view that allowed flight controllers here on the ground and Newman to confirm the alignment of Zarya and Unity, and the crew about to press ahead with the installation of Zarya, actually the docking of Unity to Zarya.
Endeavour Houston, I know you're fine-tuning it on board. Our suggestion from the downlink signal we have would be maybe to just darken it up with the iris a little bit. And assuming you have the sort of solution we're seeing, your go to pick up in FE install step 4.
Roger.
This is Mission Control Houston. This television live from Endeavour. Endeavour passing above the Pacific, altitude of 244 statute miles. On board, the crew's been given the go to press ahead with lowering Zarya toward Unity and maneuvering the two docking mechanisms toward one another. The docking of Zarya and Unity will have Mission Specialist Nancy Currie lower Zarya toward Unity to place the docking mechanisms precisely aligned with one another and only a few inches apart. At that point, she'll put Endeavour's mechanical arm in basically a limp mode, and Commander Bob Cabana will fire Endeavour's thrusters to force the two mechanisms together, docking Unity and Zarya.
Endeavour, we looked at all our camera views. We're happy, and we're going to fly it all the way down to install position. We're not going to stop part way.
We copy, Bob. Thank you. Big picture, we think from all the previous work, it'd be 10 or 15 minutes to pull it down into position. We show Earth Terminator in about half an hour, when we think the lighting will change radically towards night. So those are the sort of windows.
Chris, thanks. That's good words. And we've been lucky enough to keep the C camera on the target. If you have more recommendations for lighting for Iris or going back to auto, we'll be glad to take those. I'm hesitant to move them.
Jim, we're liking our ground solution here with the lighting that you've given us.
Okay, and Chris, tell me your ground solution for Y, please. We're going to start moving. I'm just curious what your Y solution is.
Jim, the Y solution is approximately negative 1.2.
Okay, thanks.
This is Mission Control Houston on board Endeavour. Shortly.
We're coming forward 2 inches, and curious what SDS is showing for X.
Jim, we're seeing 2 inches as well down here.
On board Endeavour, Mission Specialist Nancy Currie beginning to maneuver the Zarya Module toward Unity to align the 2 docking mechanisms. The goal to have them aligned and only a couple of inches apart in the position to be ready for the final docking. Again, slowly maneuvering Zarya toward Unity to align the 2 docking mechanisms. We'll end up with them only inches apart in the position for the final docking. While she maneuvers these, she, assisted by Newman on board, are watching the space vision system information to assist in aligning the 2 modules. Zarya, the most massive object ever moved with the shuttle's mechanical arm at more than 21 tons.
Okay, we lost the FGV up to lighting, the shadows, probably see them. We'll try to acquire.
Roger. Jim, manual iris is all we can suggest.
Yeah, okay, thanks. We've been trying to keep it dark. Yeah, we see number one's got that shadow right across it.
Roger.
Board Endeavour Mission Specialist Nancy Currie continuing to maneuver Zarya toward Unity, and the two docking mechanisms drawing ever closer. Endeavour just having crossed over Indonesia, now above the Pacific Ocean, just off the northeast coast of Australia. The payload deploy and retrieval systems are here reporting that Zarya has about 16 inches to go to reach the preferred position for the docking, while docking and installation.
Houston, SVS is running up here, and it's agreeing well with the other cues we have.
Roger, same news here, and we're showing Nancy's slow, steady pull down into position.
We're in position. We're going to hold just a little bit, and we can't get SVS just so that we confirm the two, but it looks good for berthing.
Houston SVS, we're just looking at that target number 2's got the shadow across. What are you guys doing to that one? Target number. Yeah, that's target 2.
Roger, we're looking at it, Jim. You can see the sun's just coming off it here shortly, and we think that's the solution because that's critical. However, we've seen some real good agreement between the SVS numbers on the way through and what the digitals are showing us, so that's a lot of good information. We concur with Bob's plan.
Great, yeah, and hopefully we'll have one soon.
Endeavour Houston, to set sort of a timeline, we show orbital sunset in about 18 minutes, so you'll lose the good albedo a little bit before that. And our drug would be to have the decision within the next 8 or 10 minutes, so that we'll have everything squared away before the next set of grid passes a half a rev from now.
Okay, Jim's hurrying.
This is Mission Control Houston on board Endeavour. Mission Specialist Jim Newman double checking the alignment of Zarya Unity's docking mechanisms using the Space Vision system. That's also checked using the position of the mechanical arm and the readouts from mechanical arm's joints. All of those appearing to indicate that the docking mechanisms are aligned properly. Once the crew is...
Jim, with the lighting we have now, we are showing a good solution, greens all around. Looks from our guess that you're in a good position.
Yeah, we think so, Stu. Also, back just a minute.
Once the crew's completed their checks of the alignment.
Usually, based on what we see, if we did anything, we'd move it aft in about a half an inch. And SDS also, now that Jim has a solution, says it should go aft, so we're going to move it aft and then we'll be ready.
Roger.
And Houston, SDS just lost its perfect solution there due to lighting. We have it perfectly aligned visually, and we agree with what SDS had prior to losing it.
Sounds great.
I guess what I'm saying is we'd like to go to berth Unity and Zarya.
We concur. You have a go. Picking up in step 5, we think.
We agree with step 5.
And with that, the crew will begin the procedure to dock Zarya and Unity, that to put the arm, mechanical arm, into limp mode.
And Houston, Endeavour, before we step 5, we've got to back up and pick up a couple of items for the APDS.
Roger, we're just noticing the same thing here. Thank you.
Currie putting the arm in limp mode, and then Cabana fire Endeavour's thrusters to engage the two mechanisms.
Okay, Houston, we're up to step 5, proceeding.
Thank you.
Endeavour currently above the southern Pacific Ocean at the extreme southernmost point of its orbit. The payload deployment retrieval systems officer sees the arm now in a limp mode. standing by now for Cabana to fire Endeavour's thrusters to dock Unity Zarya, engaging 2 mechanisms.
Houston Endeavour, we have captured Zarya.
Weak copy. Congratulations to the crew of the good ship Endeavour. That's terrific.
So with that, the 2 modules built on opposite sides of the world are now attached. Endeavour flew 240 statute miles above the extreme southern Pacific at about 8:07 p.m. Central Time. The docking mechanism is now damping out any motion between the 2 modules. Following the completion of that, they'll begin retraction of the docking ring, and then once the mechanism is pulled together, engage latches in the docking mechanism to firmly mate the 2 modules.
Houston Endeavour, we'd like to pick up with step 8 on the all card.
Jerry, you go.
Thank you.
Mechanical Systems Officer here reports now that the docking ring is being retracted, pulling the mechanism together.
Endeavour Houston, we lost the ring indication. Wanted to check with yours.
Affirmative, Houston. Would you like us to stop? We're seeing numbers of 38, 41, and 39. CJ says it's about the same types of numbers he saw when we were driving out.
Please push button power on. Jerry?
That's complete, Houston.
And big picture, we don't think it's a problem. We just want to, since we can, we want to stop and think about it for a moment.
Understand.
That procedure by Jerry Ross paused the retraction of the docking ring for a moment while the Mechanical Systems Officer here looks at the indications to ensure that there's not a problem with the ring's alignment as it continues to retract and pull the mechanism together. Once the mechanism is pulled together, then hooks will be driven that latch into the opposite side of the mechanism to hard mate the 2 modules to one another.
Endeavour Houston, we are puzzled over what caused this, but this is what we'd like to do. From where you are now, take the push button power to off and then on, and then go to manual docking sequence and pick up in step 7 to drive out and force the alignment, and then subsequent to pull it back in again.
Okay, we're going to do a power off, power on, and then we'll go to step 7 on the manual side.
Good copy.
This is Mission Control Houston. That call to Mission Specialist Jerry Ross aboard Endeavour due to indications of a misalignment of the ring as it retracted. Flight controllers requested that Ross extend the ring again to force it to align better, and then again retract it. And the mechanical systems officer reports he sees the ring now being extended again.
Houston, we have a ring aligned light again.
Thank you.
This television view of the mechanism from the elbow camera on Endeavour's mechanical arm, looking at the ring as it extends.
Endeavour Houston, we would like a power off and then a power on. Endeavour Houston, we're losing comm going into the handover. I want to power off and power on since we have a good align and we show good nominal numbers on where the pedals are.
With indications now showing the ring aligned properly. Call to Ross.
Sequence step 12.
Okay, we've done the power cycle. Understand to pick up with step 12 manual sequence.
Good copy. See you on the other side.
To basically request that Ross again begin retracting the ring. Again, after extending it slightly and the alignment indications now appearing good, flight controllers request that he again begin retracting it, currently going through the procedures to do that. We have a momentary loss of communications with Endeavour as we switch from one tracking satellite to another. Switching from the western tracking satellite to the eastern tracking satellite. We should pick up communications again in just a minute or so.
Endeavour Houston, Jerry, we see the power on. We concur with your decision. It looks like it's heading the same way. We show two cues that both agree together that it is a slight misalignment building up, both the loss of light and the slight change in the angles of the base. So obviously something is driving it a little bit skew-G, and we'd like some time to think about whether this is something we need to worry about or not. So just hold here, please.
Yes, sir.
And with that call, Ross had begun retracting the ring again. As it retracted, the same condition developed, loss of the alignment indications, and flight controllers request that the crew pause again, which has been done while flight controllers further analyze the situation.
Endeavour Houston, for Jerry, we're looking for a multi-input solution to this, but we have an idea in the interim, and that is we think we can gain ground by driving out just far enough to get ring aligned and then drive in. We think from the small amount of data we've seen so far that there may be a way to walk it in that way. The sequence of steps would be to cycle power and pick up in step 7 of the manual docking sequence, and then drive it until we get ring aligned, and then power on. Sorry, and then power off, power on, and pick up in step 12. And same as last time, if you see the lose the ring aligned, or you get a call from us, did you see us going crooked, then do a power on cycle.
understand we'd pick up again with step 7, drive it out till we get a line. If we lose the align on the drive in, we'll do a power cycle, power off, power on. And Chris, I guess my only concern is if we have some kind of a mechanical bind-up, the more times we drive this in alternating directions, we may be creating more of a problem. Just the thought that's in the back of my head.
We're thinking the same thing, Jerry. However, it's not the only possible culprit. We'd like to try it once and see if this works.
Okay, I understand. We'll pick up with step 7 and drive out to get a ring of line, and we'll do a power cycle, and we'll talk to you.
We concur, Jerry. You need the power off and power on first.
Okay, power cycle off on first. And then do we need another power cycle off on when we get a ring of line?
Affirmative.
This is Mission Control that call to Endeavour that the crew's asked to again extend the ring and then again retract it, perform the same sequence again, which they just completed, to see if that clears the misalignment indication that has been seen during retraction of the mechanism. The mechanical systems officer reports that an indication.
We have a unit within 1 pent with a ring of line light now.
Concur, your go to pick up into 12.
Roger, going to step 12.
With the ring driven out, Ross has again gotten an indication of alignment for the mechanism and now beginning to again retract the ring.
Okay, Chris, power cycle.
Copy. I'd like you to hold there. Thanks.
This is Mission Control Houston. Flight controllers are continuing to evaluate the indications seen during the retraction of the docking mechanism on Unity. An indication of misalign as the ring is retracted during the pulling the docking mechanisms together, the ring indicating that it's misaligned as that retraction takes place. That's happened 3 times. Each time pushing a ring, each time Ross has stopped the procedure and then extended the ring again and gotten an alignment indication back after that. So flight controllers again analyzing that indication and evaluating a course of action.
Endeavour Houston off the we're picking it up now. We think the culprit, Jerry, is arm drag. Just the friction, even though we're in test mode, just the drag out of each joint being pushed in test mode is enough. Speaking with Moscow and looking at the signature, which is a steadily ramping increase as if it was a steady drag like that. It's not anything sudden that we're a jam. So what we need to do is ungrapple. We have a good capture. And Nancy, when you're ready, what we think you need on spec 94 is an item number to re-enable the brakes, and then pick up with FD ungrapple on flight sup 4-11.
Okay, we copy that, and that's what I was trying to talk them into doing, Chris. Thanks.
Jerry, looking back at 74, there was a similar effect on 74, although we don't have any quantification of it here. That's one more item in our discussion.
Okay, I know we got a lot different arm configuration here, but I can tell you from on STS-37, when arm was in limp mode, it's certainly not limp. We tried to move it with EVA hands.
Roger that.
This is Mission Control Houston. That call to Endeavour with the plan to attempt to retract the docking mechanism again. For that, the thought after evaluating the situation is that the problem may be in the arm, the mechanical arm for Endeavour that's attached to Zarya. That drag from that arm may be causing the misalignment as the ring retracts, pulling the mechanism together. So the crew's been requested to have the arm release Zarya. Mission Specialist Nancy Currie will begin that activity to release the arm's grip on Zarya. Zarya is firmly soft mated to Unity, mated to the docking ring, the first step in the docking process. After the arm is released, then Ross will go through the same sequence again, extending the ring slightly until an alignment indication is seen, and then retracting it again to pull the mechanism together to firmly mate the two modules. Indications seen by controllers lead to a possible drag created by the arm in that the alignment appears to be happening on the area where the grapple fixture is located on that side of the docking mechanism, and a very slow drag on the mechanism as it's retracted that would be indicative of the arm, even though it's in a limp mode, still having gears and joints that are pushed down and moved by the mechanism as it pulls Zarya toward Unity. So again, the plan is that Nancy Currie will release the arm from Zarya, and then Ross will again work with the docking mechanism to extend the docking ring to gain an alignment indication, if that's necessary to gain alignment, and then again retract the ring per normal operations. And the Payload Deploy and Retrieval Systems officer here reports she sees indications that Currie has begun to release the arm's hold on Zarya. There was a mention of problems experienced during shuttle mission STS-88. The mission took a docking module up to the Mir space station. When the arm was used and attached to that module, it used a similar mechanism to attach to Mir, although the configuration for the arm and of that module were very different from what is the case with the arm almost fully extended here attached to Zarya. A situation on this flight that could cause more drag on the mechanism as it is retracted. Engineers evaluating the problem report that the
Houston, we got a ring of line light as soon as the arm was released.
Looks like the smoke and gun in this problem, Jerry, looking very promising. We'll get you the right spot to pick up in the manual sequence.
And with the arm released, Ross reporting that he sees an alignment with that may have indeed been the problem. Standing by now for
Houston, Jerry, we're seeing a little motion as since we released the spring, it's getting itself back to a steady position. Once we've seen enough of that, we'll be asking you to pick up in step 12.
Okay, thanks.
That call asking the crew to wait for the mechanism to steady before beginning to again retract the ring. Engineers also reporting that they had seen the indications on the pedal nearest where the grapple fixture was of the main misalignment. Another situation indicative of...
Yeah, Chris, I presume you'd like the arm remain poised where it is.
Endeavour Houston, Nancy, we concur with your plan. We'll be planning the survey once we get the APDS ops complete, as long as it's clear of as required for now. Endeavour Houston for Jerry, we are happy that the APDS has settled out. Your go to pick up in step 12 of the manual docking sequence.
Okay, step 12, we'll do ring in. Thank you.
Okay.
Ross again retracting the ring mechanism. Alignment remaining good so far. As the ring begins to pull the two modules together, again pulling them together, and then hooks will close. 24 hooks actually that firmly attach the mechanism. Mechanical Systems Officer reports that everything looks good as the mechanism pulls together. Mechanical Systems Officer reports that the mechanisms are firmly together now, and now hooks are driving to seal them together. Per normal operations, everything going very smoothly, no misalignment, the docking mechanism nearing completion. We now have live television from Endeavour, this showing Zarya and Unity. Endeavour currently above the Mediterranean. The hooks closed now, the docking mechanism firmly attached together. And Unity and Zarya attached and the International Space Station beginning assembly in orbit.
Endeavour Houston, nice work, Jerry. And for the commander, your go for attitude control. It's in the plan timeline on 3-34, about halfway down. As listed, you can see the DAP call out just above it, A12, B12.
Good work, Houston.
With you attached to Zarya now, the International Space Station rises 76 feet above Endeavour's cargo bay, seen in this live television from Endeavour. More than 7 stories above the space shuttle. This docking mechanism is the main attachment between...
Endeavour Houston, while you're loading the DAP, if you change to inertial instead of free, it'll damp the rates. Thank you.
Between the U.S. and Russian segments of the International Space Station, this mechanism never to be opened again and remain sealed throughout the lifetime of the station.
Endeavour, we show ourselves complete with the manual docking sequence, and we're off the card at step 25.
We concur.
And Nancy's picking back up in the PDRS checklist at step 7.
And Chris, if you would hand down to Tim Terry that his devious mind certainly helps on orbit.
We concur. It's been a fun day.
I might also note, Chris, that Jerry did tell me to try and grapple before you did, and there was no way I was about to do that.
Roger.
That call down to the crew, thanking Tim Terry, the simulation supervisor, for the training for the flight, who devises problems throughout the crew's training, include problems very similar to the one experienced.
Endeavour Houston, we think we need item 19 to get the go into the attitude that you just loaded.
Thanks, Chris.
Sorry it wasn't in the procedure there.
Mission Control, this television is live from Endeavour, again showing the fully attached, docked Zarya Module. Endeavour again is crossing above Russia.
Houston, Endeavour for PDRS.
We are 2 minutes to handing over to Tidris Z. Go ahead.
Chris, would you like me to go to the Z tour antenna action at this time?
Affirmative.
And how's KU coverage going for the next while?
This television view from Endeavour.
Swinging through to attitude and such. We have good video right now, and we're checking how it's going to be.
This view of the full.
We reported on board.
Okay, looks like the first 10 or 15 minutes on the west will be good.
Copied.
View of the full International Space Station as it begins assembly, towering more than 7 stories above the payload bay of Endeavour, a total of about 76 feet. The wingspan, tip to tip of the solar arrays, about 78 feet. He and Zarya mated together, have a mass of almost 80,000 pounds.
Houston, Endeavour.
Go ahead. Intermittent comm. We're on Tidris Z for another 2 minutes, then we'll have you on west. Go ahead.
Okay, Chris, we saw a good CSP switched back to ODS. We show ourselves complete with ABS ops and out of the PDRS checklist.
Concur, and congratulations. That was a big step.
Okay, and Jen and I are moving on to ODS volume prep for ingress.
Roger that. And the no need to wait 20 minutes. We've already confirmed a tight pressure vessel.
Thanks for those words, Chris.
Endeavour Houston with you on the west, and we're getting downlink video.
This is Mission Control Houston. This television picture from Endeavour showing the International Space Station as Endeavour moves into sunrise, currently above Russia.
The two antennas right here.
This is Mission Control, and this view shows the Toru antenna located in the center of this picture on Zarya, one on this side and one exactly opposite on the other side of the Zarya. Again, those two antennas not deployed, as indicated earlier by the crew as they inspected Zarya. And in keeping with indications seen by ground controller Zarya earlier on, shortly after its launch and arrival in orbit. Again, this view is of a Toru antenna telerobotically operated rendezvous system, a manual backup rendezvous system to the Currie's automated rendezvous system, which is actually the primary system to be used later on during assembly of the station for docking of Zarya and Unity with the service module.
Endeavour Houston, Nancy, that view out of the end effector is telling us a lot.
The foreground in this view is the...
We'll zoom in a little more here in a minute.
In the foreground in this view, the long pole is a reflector for the antenna, and the antenna itself, which is not deployed, is in the back of that reflector. And this view showing the still rolled up antenna that has not deployed.
How's that, Chris?
It's great. Of course, changing in lighting is going to reveal the little dark spots underneath, but good information. Endeavour Houston, if the extra lighting on the end of the arm would help illuminate the shadow, that'd be great.
We already tried, Chris. It's on.
Nothing like sunlight.
Chris, a question for Inco.
Go ahead, Jerry.
Looking at the tips paper, it looks like we've probably got about 3/4 of an inch of radius of paper left on the reel. Is that enough for tomorrow, you think?
Jerry, first blush is that's probably enough. We'll check for sure.
Okay, thanks.
And Houston, ODS volume up for ingress is complete.
Thank you, CJ.
Houston, Endeavour.
Go ahead.
Yeah, we can get you the same shot with the electronic still camera of the one on the other side, which looks exactly the same, and have it ready to downlink when you want it.
We copy your comments, and we would like that picture. Yes, please.
Now, this is Mission Control. Again, this television from Endeavour is live. This is a view of an antenna on the Zarya Module. One of the antennas for the Toru, or telerobotically operated rendezvous system for the Zarya, a manually operated backup rendezvous system for the Currie's automated rendezvous system, which is the primary rendezvous system that will be used for future operations of the International Space Station, primarily the docking of Unity and Zarya with the service module. These two Toru antennas did not deploy as was supposed to happen after Zarya's launch. An indication of that was seen by ground controllers, although some doubt had persisted as to whether indeed that indication was true or whether it might be a faulty indication, and ground controllers had performed testing over the past couple of weeks to try to confirm one way or another whether or not these antennas had deployed. Indeed, these pictures from Endeavour do confirm that they have not deployed. The antennas are basically spooled, rolled up onto a spool that when they deploy, they're released and spring out basically from their reeled up position.
Houston, Endeavour.
Go ahead.
We'll get you the electronic still shot. Of course, we'll have an oblique angle here. We still will move around with the arm and get a more perpendicular shot when you're ready for us to go for it.
Bob, we would like you to go on to the next position now. We got just what we needed out of this one. Thank you.
Roger, could FM work?
There have been no plans.
In Endeavour, no hurry, but when you get to EPCS setup, I have one very small delta to it. Whenever.
Go ahead, Chris. I'm doing that now.
Thought you might be, Jim. It's in step 3, kind of like the second line that starts with insert 1553 PC card. Just change that line to reseat 1553 card for both PCSs.
Yeah, Roger. We understand, Chris. Thanks.
Thank you.
And Chris, when you're done looking at the zenith side?
Affirmative.
Roger.
Endeavour with a question.
Go ahead.
Chris, wondering how much live TV you got during the rendezvous and grapple, specifically looking at my call out at a little bit before 19 hours.
Jerry, let me try and summarize here. We got the little bit coming through the V-bar, and basically we saw the horizon coming through, and then nothing from there right through to post-grapple except what we saw from Zarya.
Okay, we'll try to see if we can find something to send down then. Thanks.
This is Mission Control Houston. This television view of the International Space Station as seen by a camera in Endeavour's cargo bay. This view as Endeavour crosses just off the northeast coast of Australia. The station towering now more than 7 stories out of the payload bay of Endeavour, dwarfing in fact the 50-foot long robotic arm as seen in this view next to the station. Again, the International Space Station measuring 76 feet tall with a solar array spanning tip to tip 78 feet.
This is Mission Control Houston at a mission elapsed time of 2 days, 18 hours, 58 minutes into the flight of Endeavour and the International Space Station. Following the successful grapple of the Zarya control module and the successful mating of Zarya to the Unity connecting module, a 35-ton, 76-foot-high International Space Station now towers over the payload bay of Endeavour as astronaut Nancy Currie uses the shuttle's robot arm to do a thorough video survey of the newly launched Zarya control module, this in its 17th day of flight, having been launched back on November 20th from the Baikonur Cosmodrome in Kazakhstan on a Russian Proton rocket. As Endeavour and the International Space Station fly just to the southeast of Australia, about to begin a long swing across the southern Pacific Ocean, the Orbit 2 team of flight controllers, led by Flight Director Phil Engeloff, have completed a handover from the Orbit 1 team, which presided over the rendezvous to enable Endeavour to catch up to Zarya and the eventual grapple and mating of Zarya to the Unity module in Endeavour's cargo bay. Once the capture of Zarya and the mating of the two modules had been completed, after a brief delay caused by some drag placed on the ability of the docking mechanisms between Zarya and Unity to latch up firmly due to the weight of the robot arm against the 21-ton Zarya module, the arm was ungrappled by Nancy Currie. That enabled the rings between the two docking mechanisms to perfectly align against one another, and the pressurized mating adapter docking ring on top of the Unity was then driven closed and formed a hard mate between Zarya and Unity over the shuttle's cargo bay. Once that was completed, a video survey of Zarya began. It is still in progress. One of the first items to be examined by the video cameras on the robot arm was the so-called Toru, or telerobotically operated rendezvous antennas on the Zarya control module. These serve as backup navigational antennas to provide range and closure rate information for other modules or spacecraft that would come in for dockings to either the Zarya or other Russian segments of the International Space Station. The prime method of providing navigational data to incoming modules in the Russian space program is a system called the Kurs. The Toru serves as only a backup system, so its function would not be needed until the service module is launched next summer. The service module will rendezvous with Zarya or with the International Space Station now that the two modules are joined together and other modules to follow. The service module would rendezvous next summer with the International Space Station, but the Zarya would be the active vehicle in completing the rendezvous as it closes in the final several feet to mate and dock with the service module in orbit. This view is of one of the two Toru antennas. The Toru system is comprised of a reflector antenna and a vibrator antenna. It is believed that the two reflector antennas have been deployed. The vibrator antennas, for reasons not known to either the U.S. or Russian flight control teams here in Houston or at the Russian Mission Control Center outside of Moscow, the reasons are not yet known for why the vibrator portion of the antenna system has not deployed. This is very much like a party favor type of arrangement where the antenna itself, like a whip, is rolled up onto the spool that you see at the top of your view.
About as good as we're going to get with the limit we're at on wrist yaw for this antenna.
Bob, we copy. This side's a little darker. Do you have that end effector light on?
Stand by. And Houston, Endeavour, in this light setting, we don't seem to make any difference with the illuminator lights or the spotlight.
Endeavour Houston, if there's any way to manually open the iris a little bit and try and enhance the contrast here, it would help us see what we're looking for.
You should have thought of that. Good idea.
Down the hall from the shuttle flight control room in the International Space Station flight control room, Flight Director Mark Kurasich and his team of flight controllers eagerly looking at this downlink video from the shuttle Endeavour, looking at one of the non-deployed telerobotically operated antennas on the Zarya control module. Again, more like a party favor that's rolled up. The antenna itself, which acts like a whip when it is deployed to its fully extended position, is rolled up on this scroll bar that you see at the top of your view. Engineers believe.
Do you have a good, clear picture, or are you going to want us to downlink this?
No, we have a good, clear picture real time. You don't need to tape it and play it back or anything.
Engineers are carefully examining this video to determine whether the pyrotechnic pins, which are fired to release the antenna to its fully extended position, have in fact been fired. The belief is that the pyrotechnic pins did in fact fire, but for other reasons not yet clear at this point, the antenna did not deploy again. This serves strictly as a backup system to the prime navigational antenna system on the module called a CORS system, K-U-R-S. The CORS system is used to provide navigational data to other modules and Soyuz spacecraft or Progress vehicles that would be arriving for dockings to the International Space Station.
Endeavour Houston, people on both sides of the Atlantic are looking at those images, and we're getting a lot more insight into what that puts in store for us for the next 5 or 6 days. And we've gotten what we need. You're free to move on with the arm. Thank you very much.
Roger that, Houston. Thank you.
One of the things being examined by the flight control team here in Houston is whether or not astronauts Jerry Ross and Jim Newman might be asked to take a closer look at this mechanism during tomorrow night's initial spacewalk. There are 3 spacewalks planned for this coming week, the first of which is scheduled to begin just around 4:30 p.m. Central Time on Monday afternoon. There apparently will be time during the first spacewalk tomorrow night for Jerry Ross, who will be mounted at the end of the shuttle's robot arm like a telephone repairman at the end of a cherry picker, to be driven over by astronaut Nancy Currie to take a very close look at this antenna should mission managers approve this technique for a visual survey, which might provide additional video or photo documentation of the antenna. It is unknown at this point whether or not anything will be done during this flight to try to free up that antenna, or whether additional analysis of the antenna's inability to deploy will be considered for future tasks by future International Space Station assembly teams. This view from payload bay cameras aboard Endeavour, looking straight up at the Zarya control module. Again, this was launched aboard a Russian Proton rocket back on November 20th. It has been orbiting the Earth in excellent condition, with just a few minor glitches to several of the systems, none of which, however, have impacted its ability to perform so far in its first 2.5 weeks in orbit, and nothing that would impact its ability to normally support station operations in the future. Astronaut Nancy Currie is in the process of moving the shuttle's robot arm further down from the Zarya control module towards the point where pressurized mating adapter number 1, which is just now coming into the field of view at the bottom of the screen. That's the black-looking device to which the Zarya is firmly locked onto now. The pressurized mating adapter 1 is at the very top of the Unity connecting module as it sits vertically in the shuttle's cargo bay. At the very top of the Zarya control module, above the solar array mast, which is at about the 1 o'clock position in this field of view, will be attached the Russian service module following its launch next summer. So the International Space Station continues to take form. It is expanding with each passing day. The International Space Station now 35 tons and 76 feet high. The Zarya control module with a wingspan of about 78 feet across through its solar arrays, now having been joined to the shuttle Endeavour and setting the stage for 3 spacewalks by Jerry Ross and Jim Newman starting tomorrow late afternoon Central Time, about 4:30 p.m. Central Time, at which time Ross and Newman will be hooking up electrical cables and connections between the 2 modules so that electrical continuity can flow between the 2 vehicles comprising the International Space Station. Again, here in the flight control room, the Orbit 2 team of flight controllers led by Flight Director Phil Engeloff on duty now. Engeloff is joined on console by spacecraft communicator Mike Gernhardt. Coming up in about 45 minutes at the bottom of the hour at 10:30 p.m. Central Time, we'll have our mission status briefing for this 4th day of Endeavour's mission. The mission status briefing tonight to feature Randy Brinkley, the International Space Station Program Manager, Frank Culbertson, who is the Deputy Program Manager for the International Space Station for Operations, and Bob Castle, the STS-88 Lead Flight Director. Again, our mission status briefing coming up at the bottom of the hour at 10:30 p.m. Central Time. The elbow camera on the shuttle's 50-foot-long robot arm now swinging down with the aft portion.
Downlink video.
Go ahead, Bob.
Yeah, Chris, are you just, how many minutes are you looking for? Just something that has a composite of everything, similar to what we downlinked yesterday?
Endeavour Houston, Bob, it's been a very busy day. We would like the best 10 or so minutes that you can put together without any extra tax, and we sure would appreciate it, but the real work has already been done today, and you've done a superb job. If I could just highlight something in the flight plan to you as well, we have this maneuver to the T attitude coming up here shortly.
Thanks for the heads up, Chris. We'll load that, and we'll get you 10 minutes of composite of the rendezvous.
That'd be great.
Again, this view from the elbow camera of the shuttle's robot arm looking down into the aft portion of the shuttle's cargo bay. That's where the Unity connecting module was housed for launch before it was unberthed and installed vertically on the orbiter docking system yesterday, giving folks an idea of the scope and size of the first two modules of the International Space Station as they rise some 76 feet or some 7 stories high over the payload bay.
Chris, we'll be starting back into the Group B power down.
We copy, Jerry. We're just gathering any deltas to it right now. We'll have words very shortly.
Copy.
This is Mission Control Houston. Endeavour and the International Space Station attached to it, currently orbiting at an altitude of 245 statute miles, about to begin a northeasterly swing across the west coast of South America.
Endeavour Houston for the Group B power down. A couple of things. One, we'd like you to leave CRT2 up through the set contraction to leave us in a good config for DEU equivalents. And then just a reminder to take IMU3 to standby.
Okay, we'll power on CRT-2 and IMU-3 to standby.
Good copy.
This view from one of the cameras in the cargo bay of Endeavour showing the robot arm being operated by astronaut Nancy Currie being lowered to its berthing position along the longeron of the payload bay of the orbiter. Its job for the day having been completed, but certainly not for the mission. It will be unfurled and unlimbered once again tomorrow afternoon by Currie, and will be used extensively to drive astronaut Jerry Ross around the cargo bay during the first of 3 spacewalks that he and Jim Newman will perform during the course of this mission. That first spacewalk scheduled to begin tomorrow at about 4:30 p.m. Central Time, in which Ross and Newman will be called upon to begin the job of hooking up cables and electrical connections between Zarya and Unity, thus providing power to the unpowered Unity connecting module for the first time. The Zarya's solar arrays, which were locked in a fixed position during the final phase of the rendezvous, and its grapple and its installation on the pressurized mating adapter of the Unity module, those solar arrays have now been unlocked on command from the Russian flight control team at the Russian Mission Control Center outside of Moscow, and are once again tracking the sun and absorbing solar power for conversion into electricity for the operation of the Zarya systems. This is Mission Control Houston, down the hall from the shuttle flight control room in the International Space Station control room. On the right, Mark Kirasich, the International Space Station flight director. To his right, on the left side of the picture, is astronaut Lisa Nowak, who is the International Space Station spacecraft communicator. They are monitoring all of the functions of both the Zarya and the Unity. Soon there will be a voice check back to the Russian Mission Control Center by Commander Bob Cabana and mission specialist Sergei Krikalev to make sure that everybody is talking to one another on both sides of the world as the 2 flight control teams work in concert with each other to monitor systems and the status of the International Space Station as it is locked vertically in the cargo bay of Endeavour. This computer-generated graphic based on real-time data being received from Endeavour, once again showing astronaut Nancy Currie lowering the shuttle's robot arm to its parked position, where it will be latched in place for the night, again to be used tomorrow in the support of the first of 3 spacewalks by Jerry Ross and Jim Newman. The astronauts are scheduled to begin an 8-hour sleep period at 3:36 a.m. Central Time. They'll be awakened on Monday at 11:36 a.m. Central Time, and about 2.5 hours later will march into their spacewalk preparations as Ross and Newman begin to suit up and pre-breathe pure oxygen to cleanse the nitrogen out of their bloodstreams. They'll be assisted down in the external airlock of Endeavour by pilot Rick Sturckow, who is the intravehicular crew member or spacewalk choreographer for this first International Space Station assembly flight. To recap the day's events, the astronauts were awakened at 10:36 Central Time this morning. 2 hours later, they marched into their rendezvous checklists, beginning the heart of the final push to catch up to the Zarya control module. A final terminal initiation firing of the reaction control system jets and the final major rendezvous maneuver was executed on time at 3:15 p.m. Central Time. That placed Endeavour on an intercepting path to arrive at a point about 600 feet below the Zarya control module. At that point, Commander Bob Cabana began to manually fly Endeavour in a loop in front of Zarya at a distance of about 400 feet, and finally to a point about 250 feet above the Zarya, from which he slowly inched his way down with the robot arm extended by Nancy Currie and the docking mechanism of the pressurized mating adapter number 1 on top of the Unity connecting module, perfectly aligned with the docking mechanism of the Zarya control module. Finally, after ensuring that the two docking mechanisms were aligned and that all was in readiness, Currie reached out with the robot arm and grappled the Zarya at 5:47 p.m. Central Time as the two spacecraft flew over the Kazakh-Russian border. Some 2 hours and 20 minutes later, at 8:07 p.m., after very careful alignment to place the Zarya just inches above the Unity connecting module's pressurized mating adapter, Commander Bob Cabana fired downward-firing jets, thus thrusting the orbiter towards the Zarya and thus completing the structural mating of the two spacecraft. It took several tries to get a perfect ring alignment because of some drag that was being applied to one of the pedals on the Zarya's ring mechanism, the docking mechanism itself, the three flanges that make up the docking mechanism itself. One of those flanges was not aligned properly, and so after backing off and re-extending the ring and then driving the ring closed once again, it was determined that the arm should be ungrappled from Zarya, since the two docking mechanisms had made an initial capture of one another. That removed the impedance that had prevented the perfect ring alignment, and the two modules were finally locked up firmly against one another with no further problem noted. So Zarya and Unity are perfectly mated. Leak checks have been conducted between the two spacecraft. A tight seal and a permanent seal between Zarya and Unity has been noted, and so the two modules are in excellent condition, according to the flight control team here in Houston and the International Space Station flight control team down the hall from here, in concert with both U.S. and Russian flight controllers half a world away at the Russian Mission Control Center in Krikalev outside of Moscow. With Zarya firmly in the grasp of Unity and the two modules in a hard mate against one another, the Zarya's solar arrays were unlocked and have begun to track or articulate toward the sun, moving with the sun to collect solar energy for conversion into electricity through its onboard batteries.
Endeavour for DPS, we're ready for G2 set contraction if you are.
We're ready, Bob.
Houston Endeavour for PDRF.
Go ahead, Nancy.
After giving the arm quite the workout today, we are complete for the day. Give our thanks to everybody in the RMS and the STS back rooms.
Okay, we copy.
And we got one more comment. If you guys talk to Dave Homan, tell him it was exactly like we saw in the VR lab, exactly.
That's great news for Dave. We'll pass it on to him, and great job to you, Nancy.
Houston Endeavour for DPS. If you're ready, we'll contract the set.
Okay, Bob, we like your NBAT. We're ready for the contraction, and in step 5, we will not be doing an error log reset.
Copy, no error log reset. Houston Endeavour GPC-2 is coming to standby and then halt.
We're watching.
Houston Endeavour, we're taking IMU 3 to standby.
We copy and concur.
This is Mission Control Houston at a mission elapsed time of 2 days, 19 hours, 36 minutes into the flight of Endeavour. On board Cabana, Commander Bob Cabana is in the process of shutting off non-essential backup systems aboard the orbiter that were reactivated earlier in the day in support of the rendezvous and retrieval of the Zarya control module. Cabana is also in the process of reconfiguring computers.
Group B power down with the exception of the drivers that we need.
Yeah, Bob, we pulled the room and we concur with the Group B power down complete. And just a heads up on the galley heaters, whenever you're done with the galley, you can go ahead and turn those off.
Roger.
Again, Cabana has completed the so-called Group B power down.
Endeavour, what MET would you like to start DTO 257 at?
Bob, we're just talking about that now, and we're aiming to perform this at sunrise, which will be at 1952.
Copy, 1952.
And Bob, also in the flight plan, we've got this air-to-ground check with MCC Moscow. We're ready for that now on air-to-ground 2 if you're ready.
Roger that. We'll power down and do it.
The voice check about to be conducted. This is a planned voice check between the Russian Mission Control Center and the crew aboard the shuttle Endeavour, to which the new International Space Station is mated.
Appreciate. Как слышите нас? Да, здесь на связи все.
Мы от имени смены поздравляем вас с успешной работой и с началом освоения станции МКС, Международной космической станции, и желаем вам дальнейших успехов.
Спасибо. Хорошо, нет вопросов.
Тогда циклограмма дня входа будет изменена и до вас доведена, а методика, по которой будете работать, будет вам передана на борт.
Хорошо, спасибо. Вы будете передавать ее оттуда из Москвы или ЦУП будет передавать ее?
Мы передадим эту методику из ЦУПа Москвы в ЦУП Хьюстон, и они вам по своим средствам эту методику передадут на борт.
Понял.
Так, и, значит, я считаю, что канал проверен, канал работает, канал будет в горячем резерве, и если при выполнении данной работы у тебя какие-то будут вопросы, то мы готовы всегда на этот вопрос ответить.
Понял, спасибо. И я не знаю, вы слышали или нет, и видели ли вы картинку, но, похоже, обе антенны тоже не раскрылись.
Да, да, мы это видели, обе антенны не раскрыты, и будет, я так понимаю, работа внесена в циклограмму третьего выхода.
Понятно. И я сделал пару фотографий таких крупных на электронную камеру, так что мы сегодня вечером сбросим вниз, и будет более-менее подробная картинка еще и на фотографии.
Хорошо, спасибо, приняли.
И, похоже, отошла еще одна из панелей микрометеоритной защиты на КГБ.
Ага, понятно. Ты тоже это заснял, да?
This is Mission Control Houston. This conversation ongoing between one of the Russian flight directors in the Russian Mission Control Center in Korolyov outside of Moscow and mission specialist Sergei Krikalev aboard the shuttle Endeavour refers to congratulations for mating the first two components of the International Space Station together, and a quick systems update on the Zarya control module indicating that Zarya is in excellent shape, ready to accept the start of spacewalks tomorrow night by Jerry Ross and Jim Newman to begin hooking up the Zarya to the Unity connecting module.
Mike Gernhardt. Ну хорошо, Сергей, тогда закончили. Мы продолжаем дальше сейчас. PCS будем устанавливать. Ну, если к нам какие вопросы, мы всегда на связи. Как вам будет удобнее? Счастливо.
Mission Control Houston, that completes the voice check and initial words from the Russian flight control team to Russian cosmonaut Sergei Krikalev aboard the shuttle Endeavour.
Go ahead, Bob.
Okay, Mike. I'm sorry we missed that KU downlink time. We were looking at the tapes, and we were switching around between cameras quite a bit, and we really didn't have a chance to edit and pull out any good video. I promise we'll put something together later tonight and have it either ready to downlink first thing in the morning or later tonight.
That sounds fine to us, Bob. We appreciate anything we can get, but again, low priority.
Thanks. We just got really busy with everything that was going on.
Understand completely.
Houston Endeavour for EPCS.
Go ahead.
Okay, EPCS is all checked out. We activated it, deactivated it, everything was nominal.
Copy. Good news.
This is Mission Control Houston. As the astronauts aboard Endeavour begin to catch their breath after a busy afternoon and evening of activities in the grapple of the Zarya control module and its mating on the Unity connecting module, a test is on tap a short time from now as Commander Bob Cabana and pilot Rick Sturckow fire several pulses of the shuttle's primary reaction control system jets. This is designed to gather data on the structural stability of the International Space Station modules as they are mated to the orbiter docking system vertically over the shuttle's cargo bay. This is designed to acquire data on the type of vibrations and natural frequencies and the damping of the structures against one another based on pre-flight predictions when jets are fired, in order to understand better what impact shuttle dockings and Soyuz in progress vehicle dockings will have on the mated modules of the International Space Station in the months and years to come. The test is expected to last about 30 minutes. This is not unlike similar tests that were conducted when space shuttles were mated to the Russian space station Mir to gather preliminary data on how shuttle jet firings of the primary reaction control system jets would have, what type of reaction that would have against the full stacked structure of multiple space station modules. So that structural dynamics test is coming up in the next several minutes as Commander Bob Cabana and Rick Sturckow take about 30 minutes out to fire the shuttle's primary reaction control system jets in a data gathering exercise on the structural integrity of the mated International Space Station modules as they rise above the shuttle's cargo bay.
And Houston Endeavour, do we have a go for DTO 257 at 1952, or do you want us to wait till the sun's really up?
Stand by, Bob. We're going to refine that time for you.
Yeah, I guess what I wanted to say was, can we wait until we have a good picture in the CTVC before we do the test so we get a good recording?
Yeah, Bob, that would be the criteria, just your judgment as to when you have a good picture.
Thank you.
Houston Endeavour for ICBC.
Go ahead.
Okay, Mike, we got 3 shots in for ICBC today. The first one was after grapple, but at sunrise, 30 seconds long, F11. A second one was at F11 as we were transitioning to the pre-install with the Earth in the background. And the third one was with the FGB mating. That one was at F8. Ending film was 2131.
Okay, we copy, Joey. We want to verify that you went to standby disable on the camera.
That's in work right now.
Copy that.
This is Mission Control, astronaut Jerry Ross, filing a status report on the types of scenes that were captured by the IMAX cargo bay camera, which is mounted in the payload bay of Endeavour, documenting the historic first steps in the assembly of the International Space Station. This is Mission Control Houston. This view of one of the solar arrays on the Zarya control module. This will be the view for flight controllers as they take a careful look at how the primary reaction control system jet firings excite those solar arrays as the Zarya is now mated to the Unity connecting module above Endeavour's cargo bay. Those solar arrays measure some 80 feet across, a full wingspan for the Zarya. They were unfurled just 13 minutes after launch from the Baikonur Cosmodrome back on November 20th, collecting solar energy for conversion into electricity through the onboard batteries, while the Zarya has traveled in darkness for 45 minutes out of each of its 90-minute orbits.
A little bit of harsh light on the solar arrays with the reflection off them, but we got what we think is a good picture of the tips of both arrays on cameras A and C. If you've got KU, maybe you can take a look downlink.
Yeah, we're looking at it, Bob, and we're talking about it. Stand by.
Coming up just a moment from now, our mission status briefing for this evening. We will be able to provide any replays of video that may be downlinked during the mission status briefing. Once again, the mission status briefing is coming up just a moment from now with Randy Brinkley, the International Space Station Program Manager, Frank Culbertson, the Deputy Program Manager for the International Space Station for Operations, and Bob Castle, who is the Lead Flight Director for the STS-88 mission. Again, our mission status briefing coming up just a moment from now on NASA television, and we will have the ability to replay any downlink video of any interest or of any importance following the completion of the mission status briefing.
Bob, we're still checking with the MER to make sure everybody's happy with the quality of the image. We'll get right back to you.